Good morning, dear students. Welcome back. I am your physics professor Dr. Nagaraj. So I am continuing with the discussion of model question paper number 1, and it is exclusively for computer science and allied branches stream. So here is the module number 4. In this module you can expect questions from quantum free electron theory, classical free electron theory and superconductivity. This is the question paper pattern. I already showed this even in the previous videos also. So each module will be consisting of 2 full questions and you have to answer any one full question. And now I am going to talk about module number 4. There are 2 questions, number 7 and 8. Either you have to answer question number 8 full or 7 full. 7 ABC or 8 ABC. Keep this in mind. It is not that 7AB and 8C or 7A and 8BC. Not like this. Either you have to answer full 7ABC or 8ABC. So instructions are very important. Though you know the answers, because you are not reading the instructions properly or without knowing the rules and regulations properly, you will end up in the problem. So just to avoid that, I am reminding you again and again. Okay, dear students, this is the question paper pattern. Question pattern. There will be ABC and ABC. Here comes question number 7, 7A. 7A goes like this. Enumerate the failures of classical free electron theory and assumptions of quantum free electron theory of metals. Dear students, we all know each and every substance. See, I am not only explaining the answer, I am just giving the background of that so that you can remember the concepts in a better manner. Okay, so we know each and every substance is made up of atoms. Atoms are in turn made up of electrons, protons and neutrons. But still their electrical properties are not same. Some are very good conductors, some are very good insulators, some are dielectric, some are in semiconductors, like this. So why this difference? And some materials allow electric current and thermal energy both. Some materials allow only thermal energy. The specific heat is more. Some substances specific heat is less. Like this, there is a diversified property in thermal as well as electrical behavior concerned. So in order to explain the thermal property and electrical property, many theories were proposed. This is just an introduction. You need not have to worry about all these things, and you need not have to write all these things. So first theory is classical free electron theory. Classical free electron theory met with many failures. There were very few successes, hardly 1 or 2 successes, but majority failures only. Now we have to list 3 failures here. Number 1, classical free electron theory failed to explain the variation of resistivity with respect to temperature. According to classical theory, resistivity is directly proportional to square root of temperature. But we know resistivity is directly proportional to temperature. So this is the first failure. Just much is enough. Okay, just write the failure and give defending answer or defend your answer by giving suitable equations. Like here, classical theory says rho is proportional to root T, but experimentally we know rho is proportional to T. So that's all about this first failure. Coming to second failure, classical free electron theory failed to explain the variation of specific heat with respect to temperature. In worst case, this first sentence itself is enough, but it is better to write 1 or 2 more lines. Bari ನೀವು it failed to explain the specific heat variation andre some evaluators may consider and give full marks. Some may not give full marks because that is not the complete answer. Okay, so examiner will give full marks only if you are in the border case. By giving extra marks, if you are getting through annotara idre, they will consider this answer, otherwise they will deduct marks. Full answer anna bariyodu yavattu olledu. Safer side, you write the complete answer. What is that complete answer? Here, according to theory, specific heat is 3 by 2 R. So you are defending your answer by giving equation. CV equals 3 by 2 R anta helutte theory. And also theory says specific heat is independent of temperature. But experimentally, specific heat is very small, about 10 power minus 4, and moreover, it varies with the temperature. And we always go with experiment. Theory is theory. Theory is based on many assumptions. Experiment is ultimate. So Theoretically, specific heat is very high and independent of temperature. Experimentally, it is very low and depends on temperature. Therefore, this is another failure. Now comes one more failure. According to classical theory, electrical conductivity increases with increase in free electrons. As number of electrons increases, conductivity also increases anta helutte classical free electron theory. According to that theory, aluminum, gallium, they are all trivalent. Per atom you have 3 free valence electrons. Per atom 3 free electrons or valence electrons. Free electrons andru ondene, valence electrons andru ondene. So that way aluminum and gallium trivalent must be much better than copper. Copper is not a trivalent, it is a monovalent. But copper is better than aluminum, you know. Copper is a very good conductor, silver is a very good conductor, gold is a very good conductor. Gallium is not a conductor at all. When you combine gallium with semiconductor like germanium or silicon, you get p-type semiconductor. So what I mean to say, classical theory's prediction that as n increases, sigma increases is not correct. Sigma does not depend directly on n. It may be true in 1 or 2 cases, but not universal. So adanne nanu illi helidini. According to theory, electrical conductivity increases with increase in free electron concentration. Hence, trivalent elements like aluminum and gallium should have higher conductivity compared to monovalent element like copper and silver. But it is not so. Silver and copper are far better than aluminum, gallium. Therefore, classical free electrons theory's prediction is wrong. So these are the 3 assumptions. Assumptions part over. So maybe 3 marks are reserved, 1 mark per assumption. Now coming to the for failure. So failure part is over. Now coming to assumptions. In this question we have both. You have to enumerate failures of classical theory. Also you have to list out the assumptions of quantum free electron theory. ನೋಡಿ quantum free electron theory assumptions ಅನ್ನು ಹೇಳ್ಬಿಡ್ತೀನಿ, ಅಲ್ಲಿರೋದನ್ನೇ ನೀವು ಆಮೇಲೆ ಓದ್ಕೊಳ್ಳಿ. Number 1, according to quantum free electron theory, energy is not continuous, it is discrete. Electrons possess individual energy, discrete energy, and energy states are discrete. So first assumption, energy of conduction electron is quantized and electron possess discrete energy. Second one, see in each energy level there will be distribution of electrons. Each energy level can accommodate some definite amount of electrons. You cannot accommodate all the electrons in the same energy level. Like your college desk, so your desk where you sit, it is having a definite size. It may be capable of accommodating 4 students. So maximum number of students can be accommodated in one desk is 4. So that is depending upon the size of the student. So accommodation or filling or distribution of students in the classroom in the desk is governed by certain facts, certain parameters. Similarly here also, in a container, in a metal, there are so many energy levels, but electrons cannot go and sit wherever they want, and they cannot sit, any number of electrons cannot sit in a given energy level. Distribution is governed by Pauli's exclusion principle. Idu explanation ಆಯ್ತು, ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ. ಈಗ ಆನ್ಸರ್ ಅನ್ನು ನೀವು ಇಷ್ಟೆಲ್ಲ ಬರೆಯಕ್ಕೆ ಹೋಗಬೇಡಿ, ಡೆಸ್ಕ್ ಎಕ್ಸಾಂಪಲ್ ಎಲ್ಲ ಕೊಟ್ಟಿದ್ದು ನಿಮಗೆ in order to convince you, that's all. Okay, now you write the answer like this. The distribution of electrons in the allowed energy levels is based on the Pauli's exclusion principle. And you know what is Pauli's exclusion principle? Each electron can have, no 2 electrons can have all the 4 quantum numbers same. So that means you cannot find 2 electrons identical. They are having same principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. If there is 1 electron with spin up, there will be 1 electron with spin down. According to Pauli's exclusion principle, in a particular orbit, in particular level, you can find only 2 electrons. So that is the limitation of the number in a particular energy level. Hage the size of the student decides the number anta ಹೇಳಿದ ಡೆಸ್ಕ್ ಅಲ್ಲಿ. If the student size is the deciding factor for accommodating the students in the desk, Pauli's exclusion principle is a deciding factor for accommodating electrons in a given energy level. So this sentence is like that. Distribution of electrons in the allowed energy level is based on the Pauli's exclusion principle. According to this principle, each level can accommodate maximum of 2 electrons. This is the next assumption. Next, there exists a level called Fermi level. So filling starts from the bottom, proceeds to the top, and at one particular level the filling has to stop. That level is called Fermi level. Fermi level will separate occupied level from unoccupied level. So you better talk about Fermi level, mention this as the assumption. So in a metal there exists Fermi level which separates occupied states from the unoccupied states. Got it? So Fermi level is therefore highest occupied energy level. So here is the answer. Fermi level separates occupied states from unoccupied states. Okay. Next, electrons in the energy level above the Fermi level behave like free electrons. This is also one of the important assumption. See, this is a Fermi level. Above there is a vacancy, below there is a occupancy. Now you raise the temperature. These electrons which are near the Fermi level will go and sit above this. Now once they come above the Fermi level, they become free. They can move randomly. They can collide with each other. So then I can call it as free electron. As long as it is in the Fermi level, as long as it is below the Fermi level, I cannot call it as a free electron. So according to Lorentz, who suggested this theory, Sommerfeld and Lorentz theory, according to them, electrons above the Fermi level are considered as free electrons and they keep on moving and colliding each other. So these are the assumptions. I read them once again. Energy of the conduction electron is quantized. Quantized ಅನ್ನೋದು ತುಂಬಾ important. That is why it is called as quantum free electron theory. And each electron possesses its own energy level. Next, the distribution of electrons in the allowed energy level is governed by Pauli's exclusion principle. Number of electrons in any level is maximum 2. Fermi level separates the occupied from unoccupied states. Fermi level is the highest occupied level, and electrons above the Fermi level are free electrons and they collide with each other, and attraction between free electrons is neglected, and electrons and lattice point is attraction between the free electron and lattice point and repulsion between electrons ignored. Attraction between electron and positive ignored, repulsion between electron and electron is also ignored. So these are the assumptions. Actually 4 marks, but I have given 5 assumptions. Anyway, this is not a problem. One extra ಬರೆದ್ರೆ ಏನು ತೊಂದರೆ ಇಲ್ಲ, ಕಡಿಮೆ ಬರೀಲಿಕ್ಕೆ ಹೋಗಬೇಡಿ. Okay, with this I move on to the next question. Now explain the Meissner effect and variation of the critical field with the temperature. This is about superconductivity. First I will explain the Meissner effect. Meissner effect. When a superconductor above the critical temperature is placed in the external magnetic field, it allows the field lines to pass through. Now you have a piece of superconductor, keep it in the magnetic field, apply the magnetic field, the lines will pass through the specimen. When the substance is at a higher temperature, T greater than Tc. That means it is not a superconductor right now. It is a superconducting material, but not yet acquired, not yet achieved that superconducting state. Normal agide adu. If you apply magnetic field, lines will pass through. Now if you reduce the temperature below critical value, now the substance becomes superconductor. Lines cannot pass through. Lines will be thrown out of the specimen. So lines which are earlier going like this, now they go like this. This was observed by Meissner, hence it is called as Meissner effect. I read it. When a superconductor above the critical temperature is placed in the external magnetic field, it allows magnetic lines to pass through. If now the temperature is reduced, means it is cooled below critical temperature, magnetic lines are expelled, thrown out. ಯಾವ್ದು ವರ್ಡ್ ಆದ್ರೂ ಬೇಕಾದ್ರೂ ಬರೀರಿ, ಮೀನಿಂಗ್ ಸೇಮ್ ಇರಬೇಕಷ್ಟೇನೆ. Okay, kicked out ಅಂತ ಕೂಡ ಕರೀತಾರೆ. In some cases, some people call it as kicking off lines. Thrown out of the specimen, expelled from the specimen, removed from the specimen. All these things finally will give the same meaning. Expelled from the interior of the specimen. This is known as Meissner effect. This Meissner effect, diagrammatically I can show like this. See, this is a superconducting sphere and temperature is above Tc and lines are passing through. Dear students, I feel I am little bit fast, but it's not that much fast. I hope you can follow. Okay, ತುಂಬಾ ಫಾಸ್ಟ್ ಏನಲ್ಲ, ಸ್ವಲ್ಪ ಫಾಸ್ಟ್ ಇದ್ದೀನಿ. Faster than what I teach normally in the classroom, because this is a time limited video. If the length of the video is beyond 25 minutes or 30 minutes, even you people also gets bored. This is a general tendency. That's why I am increasing the speed, reducing the time, and also I am explaining only one question only. One question only you watch. Okay, watch the video, try to understand, close the video and write the answer. Practice it. That's all. That is more than sufficient, I tell you, dear students. Okay, well, so the lines are passing through because temperature is above critical value. Now if you reduce the temperature below critical value, see, all the lines are thrown out, not even a single line is existing inside. This is known as Meissner effect. Okay, now there is another part in the question, critical field with temperature, variation of critical field. First of all, you have to tell what is this critical field. ನೋಡಿ, ಒಂದು ಸೂಪರ್ ಕಂಡಕ್ಟರ್ ಅನ್ನು ನಾವು ಸ್ಪಾಯಿಲ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ either you can increase the temperature or you apply the magnetic field. Now don't increase the temperature, retain the temperature below critical value. Now keep on applying the magnetic field. At one stage, magnetic lines will pass through the specimen and the specimen is no more superconductor. So that minimum external magnetic field required to destroy the superconducting property is known as critical field. I repeat, critical field is the minimum external magnetic field required to spoil the superconducting property. Here is the statement, minimum external field at which superconductor lose its superconducting property and converts into normal conductor is known as critical field. It is a function of temperature. As temperature increases, critical field decreases. Here is the relation and you can expect numericals only on this equation. Hc is the field at any temperature T. Hc naught is the critical field at 0 Kelvin. Tc is the critical temperature. Please try to understand. Hc ಅನ್ನೋದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, Hc ನಾಟ್ ಅನ್ನೋದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಬಟ್ Hc is the magnetic field at higher temperature, Hc naught is the magnetic field at 0 Kelvin. Tc is obviously critical temperature. Now the graph of H versus T, the explanation is given here. Hc naught and Tc. Hc naught critical field at Tc alla, please change is critical field at 0 Kelvin. Critical field at 0 Kelvin. This is a mistake, it is not at Tc. Right? Now I have a graph. See, Hc naught is a field at T. H is taken along y-axis, T is taken along x-axis. When temperature is 0, H is maximum, that is Hc naught. So Hc naught is the critical field at 0 Kelvin. And this is a temperature. So this graph is very important. This yellow region represents superconducting state and this region represents normal conducting state. Okay, now let us move on to the next one. Now it is numerical problem. A superconducting tin is a material, has a critical temperature of 3.7 Kelvin. Nodi, critical temperature kottidare, Tc is given. At 0 magnetic field, of course there is no magnetic field applied, and critical field is 0.0306 at 0 Kelvin. What is this then? Sir, it is nothing but Hc naught. Nodi, whenever a problem is given to you, you have to read the problem carefully, analyze the problem carefully, try to understand the contents of the problem carefully, and then list the data given in the problem. Then problem 50% solved. See, the major problem with the problem is the very first step itself. We normally don't try to understand the problem at all. If you understand the problem, then solution becomes very easy. I tell you, there is no problem without solution. For every problem there is a solution. Even in your life also, for every problem there is a solution. There are so many problems we are going to face in our life, but remember, don't run away from the problem, whether it is a personal problem or professional problem or problem with your academics. ಯಾವುದೇ ತರ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇರಲಿ, ಯಾವ ಪ್ರಾಬ್ಲಮ್ ಫೇಸ್ ಮಾಡಕ್ ಆಗಲ್ಲ ಅನ್ನೋ ತರ ಇಲ್ಲ. We can confidently face. Swami Vivekananda, you might have heard of this great personality of our country. He said once, if you pray God for wealth, okay, just I take 1 or 2 minutes, please don't get bored. This is a small piece of advice. If you pray God for wealth, God will give you opportunity. If you pray God for confidence, God will give you problems to solve ಅಂತ ಹೇಳ್ತಾರೆ. ಅಂದ್ರೆ ದೇವ್ರ ಹತ್ರ ಹೋಗ್ಬಿಟ್ಟು, ದೇವರೇ ನನಗೆ ಒಳ್ಳೆ ಅವಕಾಶ, ಸಾರಿ ವೆಲ್ತ್ ಅನ್ನ ಕೊಡು, ನೇಮ್ ಅಂಡ್ ಫೇಮ್ ಅನ್ನ ಕೊಡು ಅಂತ ಪ್ರೇ ಮಾಡಿದ್ರೆ, ಗಾಡ್ ವಿಲ್ ನಾಟ್ ಗಿವ್ ಯು ಡೈರೆಕ್ಟ್ ATM ಕಾರ್ಡ್, ಹಿ ವಿಲ್ ಗಿವ್ ಯು ಗುಡ್ ಆಪರ್ಚುನಿಟೀಸ್ ಅಂತೆ. ಯು ಗ್ರಾಬ್ ದಿ ಆಪರ್ಚುನಿಟಿ ಅಂಡ್ ಯುಟಿಲೈಸ್ ದ ಆಪರ್ಚುನಿಟಿ, ಪುಟ್ ಯುವರ್ ಎಫರ್ಟ್ ಅಂಡ್ ಕ್ಲೈಂಬ್ ಅಪ್, ಯು ವಿಲ್ ಗೆಟ್ ದ ನೇಮ್ ಅಂಡ್ ಫೇಮ್. Like that, if you pray God for confidence, ಏನೋ ನನಗೆ ಭಯ ಆಗ್ತಾ ಇದೆ, ಕಾನ್ಫಿಡೆನ್ಸ್ ಇಲ್ಲ ಅಂದಾಗ ದೇವರು ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅನ್ನ ಕೊಡ್ತಾನಂತೆ. ಬೈ ಸಾಲ್ವಿಂಗ್ ದ ಪ್ರಾಬ್ಲಮ್ಸ್ ಯುವರ್ ಕಾನ್ಫಿಡೆನ್ಸ್ ಲೆವೆಲ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್, ಅಂಡ್ ದಿಸ್ ಇಸ್ 100% ಟ್ರೂ ಈವನ್ ಇನ್ ಫಿಸಿಕ್ಸ್ ಆಲ್ಸೋ. ಇಫ್ ಯು ಸಾಲ್ವ್ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇನ್ physics, I tell you dear students, your confidence level certainly will increase. You feel some satisfaction, you derive satisfaction by solving the numericals. Okay, so this is what Swami Vivekananda says. Okay, this is true even in physics also. In problems, physics problems, first thing, read the content, list the content, list the data with appropriate notations. Coming to this problem, critical temperature Tc given, critical field Hc not given, you have to find the critical field Hc at 2 Kelvin. So this is a Tc, this is Hc naught, this is Hc, this is T. That is what I have listed here. Tc 3.7, T 2 Kelvin, Hc naught 0.0306 Tesla, Hc question mark. Yes, I have a ready-made equation. Direct substitution, Hc naught value, T value, Tc value, substitute and simplify. I have already simplified for you. Please check this once again. 0.022 Tesla you will get. Definitely at higher temperature H will be less. I told you, as temperature increases H decreases. Conversely, as temperature decreases H increases. So this is about question number 7A, B, C. Just practice this question. I will come back to you with question number 8, A, B and C. Okay, I hope you are enjoying. I hope you are not getting bored, because I am getting very good comments from your side. I will try to solve one more model paper, and some students are asking me to do the model paper discussion for electrical and electronic stream also. I will try my level best. Most likely I will do it by within 1 or 2 days. Okay dear students, stay with me, and meanwhile like my videos, share the link with your friends also. Thank you very much.